Vanakkam and welcome to Sparrow's Innovation. Thank you for watching this series of Arduino tutorial videos in our channel. This is the 8th video of Arduino tutorial. In this video, we are going to look about analog inputs in Arduino. This video is presented to you by myself, Arun Balaji. First, we will see what is the difference between digital and analog signals. Usually, our microcontrollers are digital devices. The digital signals will be like a square wave signal. The square wave will have only a high or a low signals, a low unit in the signal. So, the high will be logical high and low will be logical low, that means either zeros or 1 will be there in the digital signals. But when we come to the analog signals will be have a variation in voltage. That means the lower level will be a 0 volt or less than 0 volt. In our microcontroller subjects, we are going to see a 0 to high only. So, the minimum range will be 0 in our analog signals, right? The 0 voltage will be in the as the minimum value of our analog signal. So, when we in the analog voltage, when we move this green lines a little above, that means when we check a little above range, there will be a some voltage range around 2.4 or 2.5 or 3 like that. So, like that there will be voltage difference from 0 to 5 volt, because we will have a 5 volt as a reference voltage in microcontroller. So, the maximum range will be 5 volt and the minimum range will be 0 volt. So, analog signals, any values or any signal is sent by any sensor, analog sensor, the Arduino will read the value in with a fraction of seconds, right. So, there will be changes in voltage in the fraction of seconds in the analog signals. So, we are going to convert this analog signals and we are going to convert this analog signal into a digital signal or digital value equivalent to this analog signal, right. So, I given an explanation by using a sawtooth waveform. The same way we can see sine wave form. This is a full wave sine cycle. So, we will be having the positive cycles alone. So, the same way the minimum range will be 0 volt and there will be variation from 0 to 5 volt in the analog signals, right. So, how we are going to convert to this analog to digital signals in microcontroller. So, normally when we read when you connect digital input devices to a microcontroller, you can directly connect it to any digital input and output pins of your microcontroller, because the microcontroller will directly read a digital signal, either it will be a logical high or a logical low. But when you are going for Arduino, you can also directly connect the digital input devices to the digital input and output pins, like from 0 to 13 is the digital input and output pins. I already explained the pin details about this Arduino in our previous videos. You can check that video, and I also given the links of the videos in the descriptions, right. So, we can directly connect the digital input devices and we can read the digital input pins values, digital input values by using Arduino or other microcontroller. If you go for analog devices, then you have to use a analog to digital conversion block between the microcontroller and the analog input devices, right. So, the analog to digital converter will do what it will do means it will convert the analog value to a equivalent digital value. That means if you read a 2 volt from the analog devices, it will convert the 2 volt into a equivalent digital value and it will give to your microcontroller based on the reference voltage. So, usually the microcontroller will have a reference voltage of 0 to 5 volt. So, depending on that, it will convert the value based on the analog to digital conversion unit, right. So, same way if you are going to connect with the analog connect with the Arduino, you can directly connect the analog input devices to the analog pins of your microcontroller Arduino, right, A0 to A5, because nowadays all the microcontrollers will have an analog to digital conversion block inside the microcontrollers. Even Arduino will have a microcontroller, that microcontroller will have an analog to digital conversion block present inside that microcontroller. The input of those analog to digital conversion block is the analog pin A0 to A5. So, you can directly connect analog input devices to those pins and we can read that value from the respective input pin, and it can convert that pin into convert that value into a digital input value, digital format, right. So, how it is getting converted? So, what kind of the format the data will be converted, right. So, in Arduino we will have a 10-bit analog to digital conversion block. That means 10 bit means it will have a 10-bit binary data. So, it will be range from 2 power 10, that is 0 to 1024 is the range of your converted digital value. right. So whatever the voltage you are providing in the analog input pin will be converted that value into 0 to 1024, right, 23. That means overall the total value will be 1024, right. So the reference voltage will be 0 to 5. So 0 voltage will be a value of 0 and 5 voltage will be the value of 1023, right. So this we can do by doing the conversion value, and if you are going to connect any sensor, you have to use these values read by your analog pin to their respective formulas. For example, if you are using a temperature sensor, the value will be from 0 to 1023, but we need the values, output value, as a Celsius or a Fahrenheit format. So for that you have to substitute these values in some formulas, so that you can get a Celsius of a temperature value in Celsius or Fahrenheit, right. This is how we can use the analog input values, and this is we can convert to corresponding values based on the sensors connected to those pins, right. So next what we are going to do means, we are going to give a connection to read a analog value. So for reading an analog value, we are going to use a voltage divider circuit. So the voltage divider circuit will nothing but two resistors connected in series. The center tap is connected to your input value, input of your analog input pin, right. So the reference value will be 0 to 5 volt. For VCC I am going to use Vin, I am going to use a 5 volt supply. Then based on the formula, V out equal to V in into R2 by R1 plus R2. If you change any one resistance value, for example, I am going to change the R1 value. By changing the R1 value, we can convert, we can reduce the voltage in the output side, right. So it will be the output by varying the resistance value, you can get a step down voltage at the output signal, right. So by using this, we can get a difference in voltage from 0 to 5 volt. So instead of these two resistance, I am going to use a potentiometer. This potentiometer will be act as the voltage divider circuit for me. So I am going to connect Arduino in a potentiometer. So I will get a value from 0 to 5 volt based on the adjustment in my potentiometer value, right. Now we are going to see how to give the connections of potentiometer with the Arduino. So for giving this connection, you need a 10 kilo ohm potentiometer. So this is the potentiometer I am going to use. So this 10 kilo ohm point we need to connect with the breadboard. So I am using a breadboard here, and by using this breadboard and the jumper wires, we can connect the potentiometer to the Arduino. So I am using a male to male jumper wires for that, for giving connection from breadboard to your Arduino, right. So now I am going to insert this potentiometer in the breadboard. The potentiometer will have 3 pins. The center tap will be your analog input pin, right. So breadboard I already explained in previous videos. The horizontal pins are interconnected and vertical are separated, right. You can see the numbers present in there. So you have to place your potentiometer in vertical direction, not in the horizontal direction. So if you place in vertical direction, 3 pins will be separate pins. If you place in horizontal direction, the 3 pins will be short circuited, right. So I place the potentiometer like this vertically. So I can give the 3 wires for my 3 pins respectively for giving the connection to my Arduino. So the potentiometer will have no polarity. So either you can use the top pin as a 5 volt or ground. The center pin will be act as a analog input pin, or else you can change the top pin as a ground and last pin as a 5 volt. Now I am going to use the top pin as a 5 volt and the last pin as ground, third pin as a ground, and center pin as a analog input. So now we finished the connection. So the top pin is a 5 volt and the last pin is a ground, and given a center pin to my A0. So we can program now. For programming, for reading the analog input value, we have to use the function in Arduino called analog read. So the syntax is analog read my pin number. So here, for instead of this pin number, I am going to use A0, I can read the analog value, and that means it will convert the analog signal to the digital signal, and it will read by your analog read function, right. For that we need a external variable to store the data, the converted data. You have to store in some other variable. I am using int x equal to analog read of a0. So that what will happen, the analog pin a0 value will be converted to digital equivalent, and then it will be stored in the variable int x. Okay. So for first we can program that. Instead of int x, I am going to use int analog value for your reference. So analog value, I have to declare that variable as a global, so that I can access from all the functions, right. So I am going to declare the variable. In this void setup, I no need to declare this pin as input pin, because for digital pin we use pin mode function to declare the variable as input or output, but for analog defaultly this is analog input pin, so you no need to declare that variable, right. So next we are going to declare the serial communication. Next I am initializing the serial port, because we are going to get the value from the analog pin, and I am going to display that in the serial monitor. For that I am going to use serial.begin 9600. Why this function is explained in previous videos. I have given the link in the description. This serial begin is used to initialize my serial port. Next, in void loop I am going to read the value from the A0, and then I am going to store it in analog value. So analog value equal to analog read of A0, that will read the value from the analog pin A0, and it will store in the analog value. Then I am going to display the variable in the serial monitor. For that, serial.print my analog value. This will display my analog value in my serial monitor. Now we can compile this program and we can verify the output. See, now I uploaded my program. The output value is 1024. That means it was in the 5 volt as my input. Now I adjusting reducing my potentiometer. You can see there is a variation in my analog value. So this is a digital converted value of equivalent voltage, right. So now it's in 0 position. Then I am increasing that, so you will get a difference value. This is just the example for analog input by using a potentiometer. Instead of this potentiometer, you can use any analog sensors, so that you can do any analog sensor projects. Thank you for watching this video. If you like this video, please subscribe and share. Please wait for other videos, Arduino tutorial 9. Thank you.